In this video, I will explain about the second law of thermodynamics and entropy. Before we begin, let me introduce myself first. My name is Nur Aisha Fitiani and my matrix number is 224700. The second law states that energy naturally spreads and becomes less useful over time. It governs energy flow and efficiency in thermodynamic system. So, what is the use of second law of thermodynamics? First, the second law helps to identify whether a process can occur naturally. Second, it defines energy quality and how it degrades over time. And the third one, it establishes the theoretical efficiency limits for heat engines, refrigerators, and chemical reactions. The first statement in this second law is Kelvin Planck's statement, which is by William Thomson. It states that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. Heat engine process on the left is possible, and in the right one is impossible, which is based on the Kelvin Planck statement. The second one is Clausius' statement. It states that it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. Now we move on to irreversible and irreversible process. In a simple way, reversible process is a process that can be reversed without leaving any trace on the surroundings, while irreversible process is the process that is not reversible. Let me show the first example of reversible process. We assume that the piston is massless and frictionless. Here, we put some grain sand on top of the piston and thereby increase the external pressure on the gas. Notice that the piston is going down and the gas is getting compressed. The movement of the piston is barely visible to our naked eye. So, if the sand grains are added and removed, the volume change will be of the same amount both in cases of compression and expansion, respectively, without changing the universe condition. Now, let's take a look at the irreversible process. There are two forces acting on the piston. The piston is moved upward quickly to a new position such that the volume enclosed by the piston becomes double to initial volume. During this expansion process, a new zone is created near the piston where the gas particles are not uniformly distributed. The pressure at any points in the new volume is different, or we can say that the pressure is not defined for the system in this intermediate stage because the system is not in thermodynamic equilibrium. So, it can be considered an irreversible process that this process is a fast process and it cannot be reversed without affecting the system or surroundings. Moreover, the final pressure of the gas is equal to the external pressure. These are the comparison of reversible and irreversible process. Next, we will move on to entropy. Entropy is a scientific concept that is most commonly associated with a state of disorder, randomness, and uncertainty. When molecule is ordered, the entropy increases. The glass of water have higher entropy because the molecule is more random than the molecule of ice. Lastly, we can see the example of entropy in campfire and boiling water. So that's all from me. Thank you for watching.